or ethnicity that is spared this devastating disease. So we're going to kind of walk through that today and learn a little bit about where the field is currently. I do have a few disclosures, contract research, and I am working on a study currently with the Altec company that I'll speak on as well. So at the Center on Aging, we really are part of the global initiative to eradicate not the Zika virus, but Alzheimer's disease from the face of the earth. And we're doing that in several different ways. We frequently hear in the media, another drug fails, and sometimes all people can see is the failures that we've achieved, but not the successes. With each failure comes a valuable learning lesson. And part of what we've begun to put together is such a clear picture of the disease and its progression, what's happening genetically, molecularly, biologically, leading to the eventual memory and thinking problems that one develops. And that is a pathway over time. And the field has really changed from thinking about Alzheimer's as that person who is struggling to get dressed in the morning, who has already suffered irreversible brain damage, to a disease process that is actually occurring over decades with individual targets for stopping this disease every step of the way. So at the Center on Aging, we are working literally with dozens of different agents for those that are normal but at risk for Alzheimer's, different agents for those that may have more advanced stages of disease. So an understanding of this process is critically important. Now, we think of Alzheimer's as a disease that affects memory and thinking, maybe behavior at times as well. And in the past, it's been largely thought of as almost a psychological disease, as if somebody, has a life experience that causes them to spiral downward cognitively. This is a medical problem. It's a biological problem. And we've understood this since 1906 when Alzheimer published his first monograph on a young patient, August D., age 51, looking under the microscope at her brain after she passed. He saw two characteristic features of disease. On the left-hand side of the screen, the neurofibrillary tangle. And this is an abnormal aggregation of what would otherwise be a normal intracellular protein forming neurofibrillary tangles. These are quite toxic and disruptive to the cell, eventually leading to cell death. And on the right-hand side of the screen, in a low-power microscope, we see the characteristic feature of amyloid plaques in the brain.